Let us consider this problem in chemical kinetics. The decomposition of N2O5 in CCl4 carbon tetrachloride at 318 Kelvin has been studied by monitoring the concentration of N2O5 in the solution. Initially, the concentration of N2O5 is 2.33 mole per liter, and after 184 minutes, it is reduced to 2.08 mole per liter. The reaction takes place according to the equation. 2N2O5, which is in the gaseous form, that gives 4 moles of nitrogen oxide, dioxide, NO2 in the gaseous form plus oxygen or dioxygen. Now, calculate the average rate of the reaction in terms of what the hours, in terms of hours, minutes, and seconds. What is the rate of production of NO2 during this period? Okay, so we'll first of all try to understand this question. So what you, that is when you are asked some question, you try to ask yourself so many questions from the question. How? The decomposition of N2O5. So what is decomposed here? N2O5 is decomposed. Okay. Where in CCl4 at what temperature? 318 Kelvin. Now this is kinetically studied by monitoring the concentration. As I already rightly said, I have told something about the kinetics where we always worry about the that is speed of the reaction. Okay, right. That is how far the reactants are getting decreased. The concentration is getting decreased. Okay, so that's what we are stressing here. So initially the concert, and that is why rate of the reaction always depends on initial concentration of the reactant. So initially the concentration of N2O5 is 2.33 mole. You just look at the problem. The initial concentration is given here very clearly as 2.33 mole per liter. That is the molarity, is it not? Right. Then after 184 minutes, that is the time taken, is it not? So the time taken is for the reaction to complete or half the way or to certain extent. We cannot say half the way. So it is reduced to 2.08 mole per liter. So duration during this period of 184 minutes, it is reduced to what is the initial concentration then 2.33 mole, and it has come down to 2.08 mole per liter. So it means there is a drop in the concentration. That's what we have studied in the rate of the reaction, that is kinetics, is it not? There is a drop. And what happens to this drop? That would have been converted into the product, is it not? Right. So the reaction takes place according to the equation. So it is given very clearly. Now, our objective is to find out the average rate of the reaction. So we have to determine the rate of the reaction. In terms of what? In terms of hours, minutes, and seconds. Okay. Then, what's the rate of production of nitrogen oxide? So we have to find out the rate of production also. You have to be very careful. So when we discuss about the rate of the reaction, it can be expressed as I already that is done that is in three ways. One is rate of decrease of concentration of reactant. Another is rate of increase of concentration of product. The third one is a rate of decomposition of the reactant, that is dx by dt. So let us talk about these two because the problem it is given as a rate of decrease and rate of increase of product, rate of decrease of reactant and rate of increase of product. Now let me ask you one simple question. What is the reactant? The reactant is N2O5. What is the product? NO2. So which is decreasing? N2O5 is decreasing. Which is increasing? NO2 is increasing. That's what they have asked. You understand? Now let us proceed. So given here is the equation should be expressed very clearly. If it is not given, you have to produce this reaction. Okay, you have to establish this reaction. Then normally they will give. If it is not given, then you have to do this. Decomposition of N2O5 means naturally it should be decomposed into NO2 and O2. So before proceeding the reaction, ensure that whether It is balanced. So it is a balanced chemical reaction. Okay, that's good. Now all are in gaseous state. And what is the temperature? T is given as 318 Kelvin. Okay, right. Now the initial concentration of N2O5 is 2.33 mole per liter. That is given. And what is the duration of time here? That is T, 184 minutes. That can be converted into seconds by multiplying by 60. Then N2O5 final concentration, is it not? The final concentration of N2O5 is 2.08 mole per liter. What we have to find out? To find out average rate. Then in terms of hour, minute, second, and the formula to be used here is, that is the essential tool. See, when you look at the formula, problem, you should be aware of the concept as well as the formula. So here the important tool is average rate. To determine the average rate, you have to make use of this equation. 1 by 2 into minus delta n N2O5 divided by delta T. Delta, that represents the change in the concentration of N2O5. And what is delta T? That is the change in time. That is the duration. That is time schedule. So here, now let me consider, let us have a generic form. X moles of A combines with Y moles of B to give L moles of C and M moles of D, right? Now, for this, we need to find out the average rate of the above reaction. So the best way to find out is, you just look at this display. Average rate is given by minus 1 by x into delta A divided by delta T. Where from you got this? This is nothing but the x. So you have the A here. So minus 1 by x. So what we need to do? This minus indicates the decrease in concentration of the reactant. So just to reciprocate the mole, if it is x, put 1 by x. If it is 3, 1 by 3. If it is 5, 1 by 5. So it is XA. So 1 by XA, it is going to decrease. So minus 1 by X into A. Are you able to follow? And this is delta A divided by T, delta T. Delta represents what? The change in concentration. Okay, right. And suppose if it is given in D, it is an infinitesimally small change in concentration in the shortest interval of time. So where we can represent as a dA by dt. So in that case, a major difference. So you can put delta. So delta A divided by delta T. So minus 1 by x, delta A by delta T, where square bracket represents what? The molarity concentration. That is equal to now YB. So minus Y into dB by dt. Are you able to follow? Or delta B by delta T. Got this formula? Then, and what is given here? L moles of C. So 1 by L. Here it should be given positive. So 1 by L, because increase of concentration of product. So 1 by L into delta C divided by delta T, and that is equal to, that is 1 by M into delta D divided by delta T. You just look at this equation, and based on that you have to produce. Now let us go back to the original equation given in the problem, where it is given as what? 2 N2O5. Now how you have to write down? Minus 1 by 2 into delta N2O5 divided by delta T. Do you understand? And what about the right hand side? You have to introduce the plus sign. And what about the moles? 4 mole. Then reciprocate it. So 1 by 4, then delta NO2 divided by delta T. I hope now it is very, very clear for you. So first they are asked the average rate of the decrease of concentration of N2O. So you have to put 1 by 2 into minus delta T, delta N2O5 divided by delta T. Substitute and get the answer. Are you comfortable now? Okay. So the average rate is minus 1 by 2, and the N2O5 initial concentration, final concentration. So it is given, and that is why you are able to get that minus. Okay. So now you get minus of 1 by 2, etc. Now listen here. 6.79, the average rate is 6.79 into 10 power 9 minus 4 mole per liter per minute. Now, if you want to convert this into hour, then you have to do with 60 minutes divided by 1 hour, is it not? So you can put it in, so just you have to multiply or divide by accordingly with 60. If it is per second means divided by 60 second. Okay, so this is the simplest way you have to proceed. But remember that you must always apply this formula. It's very simple. Okay, right. And what about this one? Rate of increase of nitrogen oxide. Here we have to do 1 by 4. You go back to the original equation where we have got 4 NO2. So how it should be written? 1 by 2, 1 by 4 into delta NO2 divided by delta T. So that's what we have given here. Is it not? 1 by 4 into delta NO2 divided by delta T. Now just to substitute and get the answer. Is it clear? Right. Good. Thank you for watching this video.